ये बुंदेलखंड में आता है और बुंदेलखंड में पानी की बड़ी समस्या है। पानी की समस्या को देखते हुए तो हम लोग ऐसी ही फसल करते थे जिसमें पानी की कम आवश्यकता हो। तो एक संस्था है परमार्थ समाज सेवी संस्थान, उसने खरीफ की फसल में हमें फसल अमृत से परिचय कराया और उन लोगों ने बताया कि ये अगर डाला जाए तो इसमें पानी कम लगता है। तो हमने खरीफ की फसल में आपका हमारे पास तिल और उर्द था खरीफ में, तो खरीफ में हमने उर्द में और तिल में इसका प्रयोग किया, लेकिन उसमें खरीफ में लगातार पानी बरस जाने के कारण हमें पानी की बचत का तो समझ में नहीं आया। लेकिन जो आपका हमने एक चीज उसमें देखा कि जो जमीन में नमी था वो ज्यादा रहता था, क्योंकि पानी ज्यादा बरसता था, इस वजह से ज्यादा पानी की बचत तो हमारी नहीं हो पाई। लेकिन जो जमीन का हम स्तर देखते थे जिसमें ये फसल अमृत पड़ा है उसमें मेरा पैर जो है आराम से उसमें धस जाता था। बाकी जो मेरा जिसमें नहीं पड़ा रहता था उसमें मेरा पैर नहीं धसता था। तो हमने खरीफ में पानी की बचत तो नहीं देख पाई, लेकिन हाँ उसमें जब हमारा और दूसरी चीज जिसमें ये पड़ा था खरीफ में, तो जैसे तिल था, तो तिल वैसे तो करीब 25 दिन में जमीन से बाहर आता है, लेकिन जिसमें ये फसल अमृत हमने डाला था उसमें हमने ये देखा कि ये हमारा करीब 15 दिन में बाहर आ गया, और जिसमें नहीं पड़ा था वो करीब 25 दिन में जमीन से बाहर आया। तो जर्मिनेशन भी हमारा जो है इसके डालने से बहुत अच्छा हुआ। इसके बाद में खरीफ में जब उत्पादन हुआ तो हमने देखा जो तिल का हमारा उत्पादन था तो उसमें स्थिति ये आई कि जो जिसमें पड़ा था तो हमने करीब 1 एकड़ में लगभग 3 कुंटल उत्पादन किया था, जिसमें नहीं पड़ा था। और जिसमें पड़ा था उसमें हमें 3 कुंटल 70 किलो में, तो 70 किलो हमें अधिक मिला था। जब पानी इतना बरसा था अधिकांश लोगों की फसलें खराब गई थी, लेकिन हमारा 3 कुंटल 70 किलो जो है करीब 70 किलो उत्पादन हमारा इसमें ज्यादा हुआ। इसके उपरांत हमने रबी में जब ये देखा तो फसल अमृत को खरीद करके और फिर प्रयोग किया। तो हमने गेहूं में और मटर में दो में 1-1 एकड़ में दोनों में डाला था। तो उसमें हमने ये देखा कि जिस गेहूं में हमने डाला था उसका जर्मिनेशन भी जल्दी हुआ, और यही चीज मटर में हुई। मटर में हमने जिसमें डाला उसमें जर्मिनेशन जल्दी हुआ। और इसके बाद जब पानी की स्थिति आई तो पहला पानी जो गेहूं में हम ज्यादातर 20 से 21 दिन में या 30 दिन में लगा देते हैं, हमने पहला पानी गेहूं में 45 से 50 दिन में लगाया, और दूसरा पानी हमें लगा करीब 75 से 80 दिन में। इस तरीके से हमारा जो है जहां हम 4 पानी लगाते थे गेहूं में, उसमें केवल हमने 2 पानी में अपना गेहूं जो है तैयार कर लिया। यही चीज मटर में थी। मटर में हम पहला पानी जो लगाते थे 20 से 21 दिन में लगाते थे। जब हमने मटर में इसको डाला था तो उसमें भी हमें करीब 40 से 45 दिन में पानी की आवश्यकता हुई, और उसमें अभी तक हमारे खेत में मॉइस्चर है। जिसमें हमने डाला था मटर में, मटर में पानी लगता है, तो अभी तक उसमें मॉइस्चर है।
हाँ जी, थोड़ा श्याम जी को भी, श्याम जी की तरफ भी फोन कीजिए, उनको भी बात करने दीजिएगा। तो श्याम जी, आप अरविंद जी के साथ काम करते हैं और ये काफी फसल के बारे में बात कर रहे थे, जैसे राबी, खारिफ और राई, है ना। और आप इन चीजों को 2 चीजें बता रहे थे अरविंद जी अभी की उत्पादन काफी अच्छा हो रहा है और जर्मिनेशन जल्दी होता है, 10 दिन से पहले होता है। जैसे पहले 25 दिन लगते थे तो अभी 15 दिन।
बिल्कुल मैडम, प्रैक्टिकल का ही काम। और मैं तो खुद फार्मिंग करता हूँ और करीब अच्छी खेती करते हैं हम लोग, ऑर्गेनिक खेती करते हैं। तो इससे हमें ये मिला कि जो ये फसल अमृत प्रोडक्ट है तो इसमें ये है कि जर्मिनेशन जल्दी होता है और खेत में नमी भी रहती है, ज्यादा दिन तक रहती है, और
तो
पानी की भी बचत इसमें हो रही है,
पानी की भी बचत हो रही है। और तो आपको शायद अगर पानी की बचत हो रही है तो फिर इलेक्ट्रिसिटी की भी बचत हो रही है आपके बिल्स के, है ना, कम इलेक्ट्रिसिटी इस्तेमाल हो रहा है। ठीक
हाँ
है।
नहीं
और
बिल्कुल।
आपका उत्पादन कैसा है, फसल कैसा है, कितने
उत्पादन
क्विंटल्स ज्यादा हो रहा है?
उत्पादन ठीक है, जैसे बताया कि पहले से तो ज्यादा है। जहाँ जैसे हमने डाला है, मैं करीब 15 एकड़ खेत कराता हूँ, लेकिन
अच्छा।
जैसे हमने जिन खेतों में इनको डाला है, जिसमें गेहूं में और मटर में, तो उस पे उत्पादन अच्छा है। मतलब मटर का उसमें उत्पादन ही मान लीजिए कि 1 एकड़ में लगभग 1 कुंटल अधिक है, और खेतों की अपेक्षा। जैसे जो मेरे और भी हैं दूसरे खेत, तो उनमें इसमें जो डाला है तो इसमें उत्पादन अच्छा है। और गेहूं की भी बाल आल बहुत अच्छी आई है। गेहूं की अभी मतलब गेहूं की मड़ाई नहीं हो पाई, यानी थ्रेशरिंग, लेकिन उसकी बाल और उसका डेवलपमेंट उनसे अच्छा लग रहा है। जो बगल वाले खेत हैं, जिनमें और खेत है हमारे, जिनमें नहीं डला ये फसल अमृत, तो उससे इसकी अच्छी है, बाल आल भी अच्छी है, और इसका दाना वाना भी सही समझ में आ रहा है, यानी उसका
अच्छा।
खेत का कोटिंग अच्छी समझ में आ रही है।
अच्छा, आपके
हाँ
एकर्स कितना है, जमीन कितना
जी,
है आपका? जमीन जमीन कितना है आपका?
15 एकड़ के आसपास।
15 एकड़ के आसपास। और आप अकेले इस पे काम करते हैं या फिर आपके घर परिवार के अलग लोग भी काम करते हैं?
हमारी जॉइंट फैमिली है, तो हम लोग सभी लोग काम करते हैं। भाई है मेरा एक, और घर के जो सदस्य हो गए, तो
तो
सभी
आप,
लोग देखते हैं समय जी।
अच्छा, आप हमें ये बताइए कि आपने अलग क्या किया जिसके वजह से ये फर्क पड़ा है?
अलग हमें यही है कि ये फसल अमृत डाला इन लोगों की सलाह से, और जो भी लोग हैं, और तो परमार्थ एनजीओ ने भी सलाह दिया, और इन लोगों ने कि डाल के देखिए आप, अगर आपको समझ में आए तो आप फिर दोबारा यूज करेंगे ही करेंगे। तो
हाँ जी।
हमने मतलब, और तो जो हम डीएपी और ये डालते हैं तो वो तो थोड़ा बहुत डाला, लेकिन इसका भी खास तौर पर फसल अमृत डाला। और हमने सीड में मिला के, इसका बीज में मिला के प्रयोग किया, बोने के समय।
और मैम
अच्छा।
इन्होंने जो है, जो इनका वो था, जो अन्न में ये वो खाद डालते थे, उसमें इन्होंने जो खाद डाली है, यहाँ तक 20 किलो डीएपी डालते थे 1 बीघे में, इन्होंने वहां पर केवल 10 किलो का बीघा डाला है डीएपी, और उत्पादन भी बढ़ा है, और डीएपी की मात्रा भी, जो खाद की मात्रा है, वो भी इन्होंने कम किया था।
अच्छा,
हाँ जी,
बढ़िया है। तो बहुत शुक्रिया, आप आए और अपना बात यहाँ पे सबको बताया आपने, क्योंकि आपकी तरह बहुत सारे किसान होंगे जो शायद इस कोशिश में लगे हैं, और शायद उनको भी अगर ये कंपनी से उन्होंने अपनी अगर मदद ली तो फिर शायद उनको भी फर्क पड़े। इसीलिए आपको यहाँ पे आमंत्रित किया था आके बात करने के लिए। बहुत शुक्रिया, आपने ये बात सभी के साथ दिया।
एक उसमें यही सबसे अच्छी चीज हमें लगी कि पानी की बचत है अच्छी, और मॉइस्चर उसमें नमी और काफी दिन तक अधिक रहता है। क्योंकि बुंदेलखंड है हमारा, यहाँ पानी की विशो कमी है, तो
हाँ।
उस वजह से उसमें मॉइस्चर काफी दिन रहता है, और पौधा धीरे धीरे ग्रोथ करता रहता है। ये मुझे अपने अनुभव से समझ में आया है चीजें। और उत्पादन तो बढ़ेगा ही, बढ़ता है, लेकिन ये इसका काफी बहुत ज्यादा बेनिफिट मुझे इसका लगा कि इसका मॉइस्चर
हाँ जी।
काफी टिकाऊ है।
अच्छा।
एक्चुअली में मैम क्या है कि अगर पौधे में मेटाबॉलिज्म अगर सही ढंग से करवाना है, तो मेटाबॉलिज्म के लिए जो है सन और वाटर और क्लोरोफिल, ये तीनों चीजें जब मिलती हैं तभी पौधा जो है मेटाबॉलिज्म बहुत अच्छी तरह से कर पाता है। और
सही बात कही
मेटाबॉलिज्म
आपने।
के लिए जो है पानी, अगर पौधे परमानेंट
हाँ जी।
वाटर मिल रहा है,
हाँ जी।
मेटाबॉलिज्म अच्छी तरह करेगा तो उत्पादन इंक्रीज होगा।
ओके। बढ़िया बात कही है आपने, और सही है। अच्छा लगा आपकी बात सुन के। अभी हम अगले स्पीकर के पास जाते हैं, और आज के कीनोट स्पीकर, गेस्ट स्पीकर हमारे गुरुराज देशपांडे सर है। तो अभी थैंक यू अरविंद जी और श्याम जी, आप बुंदेलखंड से आके हमारे पास ज्वाइन किया और आपने सबको अपनी बात बताई। So Gururaj, that was just a sample of what really happens, and it's like a customer validation of one of the startups and the farmers who work with them. तो अभी आप अपने आप को म्यूट करके वीडियो पे रहिए, लेकिन दूसरों की भी बात सुनिए, अच्छा लगेगा आपको भी, शायद कुछ नया मिल जाए सीखने के लिए। Over to our keynote speaker for today, and such a pleasure to have you again after having interacted with you quite a few years ago. Pleasure to host you, Gururaj, and so Desh, as he's fondly known, Desh and Jayashree are the founders of an NGO, the Deshpande Foundation, and they have actually been around for a really long time and have started off to accelerate the creation of sustainable and scalable enterprises with social impact, social and economic impact. So I would like you to share with all of us of how Deshpande Foundation is taking this ahead. What are you doing differently? What are the different challenges that you face? And, how is it that the rest of us in this ecosystem can tap into you and get support in one way or the other? Over to you, sir.
Sure. Thank you. Thank you, Mukta. It was nice to hear people actually using the technology and benefiting from it, which is a difficult thing to get done in this, because a lot of people have a lot of ideas, but most of the ideas tend to be, they're all good for you, but they don't add up to any significant benefit advantage. And so I think, so the Deshpande Fund, my background is more high-tech entrepreneurship. But 15 years ago, we got involved a little bit more in working on the people in semi-urban and rural areas. And that's the effort that's been going on in Hubballi, Karnataka, and Nizamabad, Telangana for the last probably 15 years or so. And initially, we used to be a grant-making agency, but now we've shifted over to actually being an implementer, just like all of you on the call. And so what are the lessons that I've learned? Number one, I think if you're talking about technology for people who have lots of land, who are very well-to-do and so on, you have to come up with a very innovative solution, because if you come up with something that's very marginally better, people are not going to accept it, because they have the ability to absorb risk and try it out and so on. But when you start coming up with solutions for people who have 1 acre, 2 acres, 5 acres, or even 15 acres, or smaller farmers, their ability to take risk is very, very small. So whatever interventions that you come up with have to be very certain that you can actually achieve the benefit that you're talking about. And it has to be almost like bulletproof, because when people have a lot of money, and people come up with an idea, they can just go to Amazon, Flipkart, just buy one, use it, and if it works, great. If it doesn't work, no big deal. They'll just throw it away and move on. But that's not what happens. So the ability of people who have a lot of resources, their ability to take risk and try out new innovative solutions is quite a bit, right? Because they have disposable income. But the people who are marginalized don't have that ability, because for them it's an existential issue. If they do anything different than what they have done, it better work. If it doesn't work, they get into trouble big time. And therefore, that's part of the reason why you see innovation move a little bit more slowly in that segment of the economy. And so I think it's up to us to make sure that, number one, we co-create the solution with them. It has to be some simple solutions that will actually bear fruits. And as you start scaling it, and as you find the value in your solution, then you can start implementing more and more technology into it. I'll give you an example. We work quite a bit with agriculture. We have about 400 or 500 people in the field. We work with about 120,000 farmers and so on. So it's almost like a living lab. So if any of you want to try out any ideas that you have, you can always approach us, and if the idea makes sense, we will make sure that we accommodate you and give you an opportunity to try your solutions out. So let me give an example of one solution that we've been working on for the last 13, 14 years. We heard about water and water problems in agriculture from just now. So in Hubli, Dharwad, that area, North Karnataka, it's an arid land, but you get 50 to 60 centimeters of rain, which is quite a bit of rain actually. But unfortunately, the farmers don't have the water when they need it. So it just pours and it flies away. So in 2013, Ratan Tata had come to Hubli And I was talking to him and I said, hey, why don't we build these farm ponds? You dig a hole that's 100 feet by 100 feet by 12 feet, and that's enough water to store rainwaters within a farm, and that can irrigate 5 acres of land. And so Ratan said, yeah, that makes sense. So he gave us 5 JCB machines. So over the next 2 years, we did about 150 of them and proved that, number one, that actually, there is enough rainwater that's retained, and that the farmer actually gets 2 good crops and he doubles and triples the income, right? And so once we did 150, then we were very confident that it's worth for the farmer to invest money and to get it done, because he's almost like guaranteed that he will get a lot more out of it. So over the last 6 years, we did 66,000 of them, right? And the farmer paid almost 30%. We paid 70%. The other 30% came from our foundation and other CSR and so on. So we did 6,000 of those. We just launched a program to do 100,000 of them, right? So that's a large program. It's roughly over 1 lakh for each farm pond. So that's over 1,000 crore program. And 20% of it is down payment by the farmer. The other 60% is a loan that State Bank of India gives to the farmers. And then the other 20% comes from charity and so on. So the idea is, as we keep perfecting this process and technology, we can bring that difference to zero and then make it a free market economy so that you can scale it quite a bit. Now, because 100,000 is a large number, and when you scale it, you have to be able to manage your logistics and everything else. So we built the Rural Transformation Technology Center. And our CTO, Chief Technology Officer, is based in Silicon Valley. And so this particular center that builds in Hubli, it actually tracks 30 satellites and collects petabytes of data every time you want to look at anything. And so given a piece of land, we can actually recreate the history of that land from a water perspective for the last 10 years. So we can ideally locate the farm pond. And then we can use the same center to actually manage the logistics of construction, because you'll have hundreds and hundreds of these machines around the field trying to dig these holes. And so we need to manage the logistics. And then once the farm pond is built, we can use these centers to monitor how the crop is going, how well the farmer is doing, to make sure that he, in fact, does make more money and returns the loan, because we want to achieve zero default. Because at the end of it, when we get this thing done, the farmer not only has better income, better opportunities to do more things with it, with all the technologies that all of you are coming up with, but also he's got a credit rating so that he's credit worthy and he can borrow money, and his ability to take risks, financial risk, goes up, because now he has the ability to borrow some funds if he finds an idea that he thinks he wants to bet on. So I think my message to the entrepreneurs is that whenever you do something, make sure that there is a financial benefit. If you say before and after, the question is how much does the farmer have to invest to go from before to after? And is there enough payback on that particular investment? And it better be significant, so that otherwise people won't line up to get your product out. But the opportunity is huge, and India needs a lot of these solutions. And also, I think the whole land is all losing its carbon, and I think we are essentially converting all the land into desert globally. And so there's a lot of very, very good interventions that we need. At the same time, technology is progressing at a very rapid pace. The amount of technology progress that's happening is pretty amazing. So all of us, I think, if we come together, we all have an opportunity to come up with solutions. And I'm looking forward to hearing to some of those solutions that you're proposing today. So thank you. Thank you, Mukta.
Thank you so much, Desh. And I think it was nice to know that you're also welcoming others to say, if you have a challenge and you want to kind of take our solution in some way or take our support, you're welcome to come in and talk to us. I think there would be a few who would want to reach out, and probably, if you have a little more time to kind of listen in to the other presentations, like you just mentioned, probably they can connect up offline and then see. So these kind of connections continue to happen. I will now let Atif take over the rigor and hand over the baton to him. Thank you so much, Desh, for being here and taking time out. It was wonderful listening into you. So Atif has been supporting us in this initiative for quite some time. He's a part of IND, a very, very active part of ensuring that all the innovators are, game up and over. So over to you, Atif, to take over for the next. Devin, please have your video on as well. Thank you.
Thank you, everyone. Thank you, Mukta, for introducing me. So I would like to ask Mr. Devan Chandrasekharan. He is the founder and managing director of Fuselage Innovations. Over to you, Mr. Devan, for your technology and presentation. Thank you.
First of all, thank you for the wonderful initiative. Yeah. And
please be a little louder, Devin.
Yes, yes. Is it? You can hear, right?
Absolutely.
Yeah.
You can have your video on
Okay.
as well. Go ahead.
Yes. Okay. Actually, we are Fuselage Innovations. And Devan Chandrasekharan, the managing director of Untitled Chapter. We are based at Kalamesheri, Kochi in Kerala. And yes, and we are actually started with this startup with identifying some problems in the agriculture ecosystem. That it is, we know that in Kerala, the agriculture sector is very comparatively low when comparing other agriculture states, but the productivity, and we came to see in food and cash crops, productivity is comparatively higher than other agriculture states. So after the flood happened in the ecosystem, we understood some problematic scenarios, and we realized that the crop prescriptions as per the leaf analysis and some prediction works will helpful for the farmers to predetermine their farming activities. So we Fuselage Innovation identify some problematic scenarios, as well as we identify some farm management issues all over India also, and in accordingly we practice some good agricultural practices with our drones. And basically I am the aeronautical engineering background, and I decided to implement the technology perspective as in Make in India to in between the farming sector. So we started as a service model initially, and we prototyped our product, and here it is the product, that is the Spectral UAV, and also ground UAV. The Spectral UAV completely dedicated for data analysis for plant to know the exact growth details, as well as if any crop damage or deficiency is located in between the crop, as well as ground UAV that is completely dedicated for the prescription. Like currently our the developments for the for doing the foliar application of micronutrients as well as water soluble fertilizers. So here it is our data output. Like we are working with the two kind of crops specifically. In accordingly, we identifying based on the color change as well as vegetation index data. We sharing the details of plant crop growth stages and the stress levels as like a farmers friendly format, as well as we provide some prescription for concerned issues. And based on the projects, like recently during 1.5 years we interact with the 220 farmers, and we could create a profit in between them. Like instead of reducing labor shortage, we helping farmers by increasing their yield. That is, we came to see based on the pilot project that is around 30 to 45% of yield increase we can create, and as well as 70% of reduction. Like normally, we see that farmers, they identify any crop damage, they provide foliar applications to the entire crop acreage. So instead of that, we providing a controlled and spot application. Like usually instead of 200 liter per acre, we providing in between 10 to 20 liter per acre. And that mode of operation, we actually penetrating in between the agriculture ecosystem. And also our entire process, like in like a zero pesticide application, like instead of poisonous pesticides, we using bio agents against pests like Beauveria bassiana, Pseudomonas kind of. and and here it is our journey so far. Like during 1.5 year, we could work with the several in the agricultural industry partners and government of India's initiatives, and we got some grants for our product development. And UNDP India listed our project into Sustainable Development Goals Zero Hunger category, and currently we are into final stage prototyping and we estimating that we have the product launch in between next 6 months, and after that only we planning to pan India level expansions. So we Fuselage Innovations always believe technology is a great equalizer, so that we are more into good agricultural practices with our drones, and as well as our digital farmland model for prescriptions and predictions that will helpful for farmers, and also the future of agriculture perspective also we are managing with our prescribed data formats. So that's it from our end.
Yeah. Thank you, Mr. Devan. So it was really nice to know how you are leveraging the innovation drones to quantify agricultural insights and precision farming. So I would ask Mr. Budhi Prakash Gurjar to.
Yes, sir. Please share my.
I will first. Yeah, I will do it. So first, I will introduce Mr. Budhi. So he's a co-founder and the director of EF Polymer Private Limited. So they are working on water scarcity problem in agriculture and given solutions according to that. So I will share screen on his behalf. 1 second.
Thank you, Atif. In fact, I would like to tell you all who are listening and Desh, that the farmer that you heard some time ago, they are using the solution of EF Polymer. So it was a customer validation of sorts. So over to Budhi to present.
ओके, थैंक यू मैम, थैंक यू सर। धन्यवाद अरविंद जी और श्याम जी, आपने हमारे प्रोडक्ट का डेमोस्ट्रेशन जो किया है और उसका सही से एक्सप्लेनेशन किया है, वेरी गुड। प्रेजेंटेशन से ज़्यादा बेटर आपका एक्सप्लेनेशन है, और उम्मीद है आगे भी फार्मर ऐसे हमारे प्रोडक्ट के बारे में बताते रहेंगे और यूज करेंगे। I am co-founder and director of EF Polymer Private Limited, or basically EF Polymer work on the two problem. One problem is the waste, organic waste problem. Second one is a water scarcity problem in agriculture. So we are solving one problem to second problem. To solve water scarcity problem, we use biowaste like fruits, pills and other material which is increase carbon gas in the environment. So we are reducing carbon gas, and by using Fasal Amrit, farmer can reduce up to 40% water irrigation and up to 20% fertilizer. Next, please. This is our product packaging. So we are selling product from the Amazon and Flipkart website. Next, please. Okay. Okay. We currently sold up to 10,000 kg product to the farmers, and we are collaborate with the and other NGOs and FBOs in less than 5 months, or we are connected with 3,000 farmers in more than 10 districts, and we are collaborate with the OIST Japan, Orion group, and CINI Social Help Program. Basically, we are go through the social help program in Bundelkhand with the help of IIT Kanpur and government of UP, and we are demonstrate our product in Bundelkhand district, and their product result farmer already explained about the product and feedback their product. Next, please. Next. And in sustainable development goal, we are targeting three major goals, like no poverty in the below, or zero hunger, and responsible consumption in the product, and life on land, or climate center. By using okay. By using our product, we can be in manufacturing our product. We use up to 10 kg for 1 kg product. So that is our product decrease the carbon and polluted gases in the environment. That is very fruitful for the environment. Business in view of business model, we are collecting raw material from the those industries and production companies. They are converted into organic super absorbent polymer, and after this, after manufacturing, we sell the food, PO, and distributor local farmers. By using this product, farmer can save up to 40% water and up to 20% fertilizer, or it can increase 20 to 40% yield, and increase the up to 40% income of the farmer. It can be improve the finance capacity of the farmers, like double income of farmers. Next. We core team member has a 5 team member, and we are working in the different place and different project. Currently, Narayan working from the Japan, and Puranji and other team member working in the India, or they are very passionate about this product and company. Next. We have received more than 13 awards and recognized from the national government as well as the international government. Also, we have received more than 9 international awards, and like the Best Innovation Award at the President House, and Okinawa grant, or selected in the 1-year residential startup accelerator program in OICT Japan in 0% equity. A Carbon Tech Award at the Global Climate Constant Finale at the Netherlands. Okay, Okinawa First Supremacy Fund Award 2020. Next. Thank you so much. This all from my side, because farmer already explained about
Thank you so much, Buddhi. Could you please go back to the benefit slide, Atif? Because there was a request from one of the participants. Benefit slide. Yeah.
Mainly in water scarcity problem, like semi-arid, arid condition area. तो when जब किसान अपनी फसल बोता है, तो पहले तो उसको इनिशिएटिव लेवल में उसके पास पानी की ज्यादा दिक्कत नहीं रहती, बट जो सीजन जाता है तो पानी की जो प्रॉब्लम है वो आती रहती है. तो नंबर ऑफ इरिगेशन रिड्यूस कर देता है. लाइक अगर किसान को फसल को 15 दिन बाद में पानी चाहिए, तो उसका जो टाइम पीरियड है वो इंक्रीज करके 20 से 25 दिन कर देता है. तो इससे क्या होगा कि नंबर ऑफ इरिगेशन रिड्यूस हो जाएगी, और जो लाइट की और डीजल की जो बचत होगी, और साथ में पानी की बचत भी होगी, जिससे क्या होगा कि फाइनेंशियली फार्मर अपने आप को मजबूत करेगा. और साथ में ये जो खाद डालते हैं, अदर जो केमिकल से बने हुए आ रहे हैं, तो केमिकल्स जो फर्टिलाइजर आ रहे हैं वो क्या करते हैं कि इंस्टेंस तो ये प्रोडक्टिविटी इंक्रीज करते हैं, पर इन लेटर ऑन ये सोइल में केमिकल रहता है. इससे जब तक वो फर्टिलाइजर डालेंगे नहीं तो प्रोडक्शन नहीं होगा, और जो फर्टिलिटी जो सोइल्स की है वो डिक्रीज कर देता है फर्टिलाइजर. तो इसलिए क्या करते हैं, ये 20% फर्टिलाइजर को रिड्यूस कर देता है. और ऑर्गेनिक ही, जैसे पहले जो पैदावार होती थी कि ऑर्गेनिक से ही सब कुछ हो रहा था, बट ये फर्टिलाइजर आने के बाद में सब कुछ सिस्टम चेंज हुआ है, तो उसी वे की तरफ कि इसको डालने के बाद फर्टिलाइजर की कम फर्टिलाइजर डालना पड़ेगा और नेक्स्ट ईयर और भी इसमें यील्ड की इंक्रीज होगी, जिससे क्या होगा कि फार्मर की जो इनकम है वो डबल की ओर जाएगी। मतलब फार्मर कम एक्सपेंशन में मोर वो फाइनेंशियल सपोर्ट मिलेगा उसको।
बढ़िया है। आप अपना डिटेल्स प्लीज यहाँ पे शेयर कर दीजिए, और इफ मे बी यू जस्ट वांट टू टाइप इन, या बुद्धि जी आप अपने कंपनी का वेबसाइट और आपका ईमेल आईडी और नंबर ये सब यहाँ पे शेयर कर दीजिए, ताकि किसी को अगर आपसे बात करनी है तो वो आपको डायरेक्टली रीच आउट करेंगे। ठीक है?
Okay, I will text
Okay.
into it.
Yeah, you can just type that out in the chat for everyone. Okay. Atif, please take over and let's go over to the next. And Devan, could you also share your coordinates and your website link and all of that on the chat as well, please? Request all the participants to continue to do that as they complete their presentation. Thank you.
Yeah,
Atif, over to you.
Yeah, thank you, Mr. Buddhi. It was a really wonderful presentation and really got a lot of information. So I would ask Mr. Ritesh Kumar, he's the director of Progen Biolab, for his presentation. So over to you, Mr. Ritesh Kumar.
Good morning, everyone. Myself, Ritesh Kumar Vishwakarma, and our company do basically involve in ELISA kits. So we import currently from Germany. So our main ELISA kit is quinolones. Quinolones is a most commonly prescribed classes antibiotics used to treat various bacterial infections in human and domestic animals. However, excessive quinolones in food or drink can pose a serious threat to human, as it may cause CNS toxicity, blood disorder, brain, liver, or gastrointestinal dysfunctions. So it is important to their level in food products such as in meat and milk. So there are various traditional techniques like HPLC or GC, MS for detecting quinolones are the complex and expensive and laborious and time consuming process. So we introduce immunoassay techniques. ELISA means enzyme linked immunoassay, commonly preferred as a simple and reliable and rapid method and cost effective. So major problem इसमें यही है कि the use of antimicrobial agents by food animal, मतलब जो हम खा रहे हैं कोई भी चीज, उसमें अगर ये एक्सेसिव हो जाता है क्विनोलॉन्स, तो उसका हमारे ऊपर कितना बुरा इफेक्ट होगा उसको देखने के लिए हम ये किट यूज होती है बेसिकली। एंड अदर एंटीबायोटिक्स भी हम यूज करते हैं। इन 2005 the Food and Drug Administration banned fluoroquinolones used in US poultry production in order to reduce the prevalence of fluoroquinol resistance. So our main, this is the ELISA kits. This is 96 well kits plate, and it is ready to use, highly specific to quinolones and applicable for milk, tissue and other food samples like fish and all. So the main problem is to detect the quinolones in food samples by ELISA method. So ये थोड़ा सा सस्ता भी है और easily everyone can use. And we have our company have in-house testing laboratory facilities also. So we do all the things. That's it, sir. Thank you.
Yeah, thank you, Mr. Ritesh. So thanks for your presentation. So I would ask Mr. Pankaj Jakar. He's a PhD scholar at IIT Kanpur for his presentation. His presentation is on novel practice for water and soil management in zone using modified pitcher technology. Over to Mr. Pankaj.
Good afternoon. Good morning, everyone. Host has disabled participant screen sharing. So can we change it?
Pankaj, it's been enabled. Please go ahead.
Okay. Is my screen shared?
Yes, it's visible. Please go ahead.
Good morning, everyone. First of all, I would like to thank PSA's office and members of this initiative named KisanMitr for providing me an opportunity to present my idea here. So the title is Novel Practice for Water and Soil Management in Arid Zone Using Modified Pitcher Technology. So pitcher technology is nothing new. It has been used traditionally in Gulf region, Northeast India and current Sindh region of Rajasthan. So traditionally it is known as Matka Sinchai Paddhati. In this, what farmers used to do is to put the pot that they use for drinking, water drinking, and in the soil, and water used to get out of it slowly, and it used to irrigate the crops nearby. So it generally it was used to grow horticulture crops like watermelon and all these things that are here. And what we have done is we have changed this manufacturing technology, shape and other things of this picture to a new form so that water efficiency can be increased and it's along with its durability. I hope, am I audible, ma'am?
Yes, you're audible. Yeah.
So currently, coming to the problem that we are already a water stressed community, our per capita water availability has reduced from 5,000 in 1947 to around 1,544 currently. And if it goes below 1,000 meter cube per person per year, then we will be labeled as water stress scared country. Around 80% of our water used for irrigation, and our product is aimed at designing increasing the water application efficiency for marginal farmers, and it is a sort of replacement for micro irrigation system like drip irrigation, sprinkler, and all these things. Traditionally, when it comes to high water application efficiency, we go for micro irrigation, in which drip irrigation, sprinkler, and other systems are used, and they are mostly driven by energy. High amount of energy is required, and high initial capital investments are also required. So mostly they are dependent on government for subsidy in term. Otherwise, they are not feasible if we take a input output ratio for farmers. And so this is sort of a substitute for the micro irrigation drip irrigation system, and it can also be used to reclaim the soils that are degraded by the application of low quality water. That is, it can be used to reduce the soil salinity that is in there due to application of poor quality water, that is use of saline water. So this is a product. You can see that it's a 9-liter pitcher. It's ceramic shaped, and it holds water for around 12 hours. So 9-liter water oozes out in 12 hours, and it is sufficient. Moisture will be there for about 36 to 48 hours, depending on the crop condition. So once it is filled and water moves out, so no energy is required, and it's sort of micro irrigation. And to enhance the soil fertility, what we normally do is we add water soluble chemicals, fertilizers in it, and you can see that in picture also that we have coated it with neem paste so that to reduce the chances of this bacteria, or we can say that the termite problem that is common in Rajasthan region. So one piece costs around 220 rupees currently, and if we go for higher, increase the number of pieces produced, then this price can be reduced. Generally, our aim is to reconnect the farmer with the potter, the traditional bond that was there, and it has been lost somewhere in our transition from traditional farming to normal farming. So generally what we do is to put it above the soil, not below the soil, and we prepare a mound around it. We can see that first we put it in the soil and above the soil some level, and then we create and are surrounding it. We put some animal manure so that as water oozes out slowly, these manures or nutrients also moves out with the water, and then this mound is created finally, and it is filled with water. And finally we can see that these are the crops that are grown here, and it is best suitable for like marginal farmers who want to go for horticulture, where water availability is scarce along with the energy availability also. And lastly we can see this is cross section, it's there. Another important aspect of this product is soil remediation purpose. As water availability is decreasing, so we are moving towards the greater depth to retrieve the water for irrigation, generally groundwater. And as we go below, move further down in depth, water quality degrades. Soil salt availability increases, and as we continue to use that salt for irrigation, water for irrigation, amount of the salts that are available in the soil goes on increasing as water evaporates, and some of it is used by crops, and what remains there is salts. So after some time, this soil become unsuitable for most of the crops, and in many regions of Rajasthan we have seen this problem where we are retrieving water from around 300 meters, and after few seasons what we see is that after few years, say not few seasons, most of the crops do not grow there because of high soil salinity. Traditionally what we have done was to flood the whole farm with the water. It's pure or low quality or high quality, that doesn't matter, and as water seeps out, it takes salts with it below the root zone of the plant. And as and now since the water salt availability has reduced in the root zone, so more water salt sensitive crops can be grown, like pulses and all these things. So this method required huge amount of water that is not there, or it used to depend on monsoons that also erratic. So in this method, what we do is to put this pitcher on the mound and prepare a mound and fill it with water, good quality water once. As water moves out, the area around the pitcher gets desalinated, and this area can be used to grow salt crops which are salt sensitive, like vegetables, pulses, and all these things. We can see that as per that study we have done that most of the at depth of 80 mm from the top mount, most of the initially the salt level was 1000, and it has increased to around 4000 at the depth of 80 mm after 7 days. That is, we have filled this pitcher for 2 times. So we can see that most of the salt has concentrated to the outer peripheral inner region that is around the pitcher is suitable for the growing crops which are salt sensitive. This is the traditional method in which if we put the water in the here center pitcher here, and salt moves out. Funding, this product was developed by Rutag IIT Delhi, and we have started a startup named Unada Private Limited. We have got license from them, and to produce and market this product under terms of license that are there. And this startup was incubated by SIIC IIT Kanpur, and we received a Melinda Gates scholarship named IIN Foundership from Melinda Gates Foundation. And I'm just called an IIT Jodhpur, not IIT Kanpur, but since this is startup was funded by IIT Kanpur, so that's it. And these are some of the pictures that we have worked here. So these are these were placed in IIT Jodhpur campus. We have first put a mound soil around it, and these are the mounds, and centrally they are pictures, and these are the pictures that before we have grown and after grown vegetation. We are there. This is the second place we have grown some horticulture crops, and finally we work with NGOs and provide them training about how to produce this modified picture, how to use it. And since it's ceramic shape, so it is easy to retrieve it out after the use. So it can be used for 4 or 5 years, and its thickness is 25 mm. Traditional pot thickness is 7 to 8 mm. So 25 mm thickness means we can use for many seasons without breaking, easy to use, and it can be retrieved out to clean it. Regular cleaning is required, because when we pour the water in the pitcher, some salts and soils will always go out, go in with the time, and it will block it in the end. So cleaning maintenance is required. So we provide technology. Generally, first thing we do to provide training to potters at various locations, so that they can produce this picture, modified picture at their own location, to reduce the transportation cost first. Secondly, they will just act as our brand ambassador in local market, because since they want to sell it, and they are better connected with the local farmers than we are sitting here in somewhere far, about 200-300 kilometers. So it's our marketing strategy now. We have been incubated. Our startup was set up around 1 year ago, and that's it. We have sold around 500 pieces of this picture in 1 year, and these are services. We provide horticulture practices and soil remediation practices also. And this can be irrigation facility, irrigation system for kitchen gardens is there. That's it. I think my time, it has been around 10 minutes, and this is my contact information, our companies. And if anyone have any questions, you are most welcome, sir.
Yeah, thank you, Pankaj. Thank you very much. It was really nice to know about the novel practice and how you are using the pitcher technology. So thank you, everyone. So I will ask Mukta ma'am to further take it forward.
Thank you so much, Atif. Thanks, Pankaj. Good to have you here again and presenting something different than what you've done earlier. Could I request all the participants to switch on your videos, please? Devin, Ritesh, Pankaj. Yeah. Atif, could you take a screenshot of all of us so that if anyone wants to share it on social media handles, they could do the same. It would be good to have you all. Please share your details on the chat, Pankaj, as well. You can do it there. And so I have a piece of news for all of you who are signing in now, that Mr. Gururaj Desh is very interested to have a look at your presentations and see if he can help you in one way or the other. And Buddhi ji, especially आपके लिए एक lead भी आ चुका है, right? If you can see on the chat, there's a lead for you, and I think you should take it forward. Very good. See, this is the kind of culmination that we are talking about. When we say a webinar, we don't want the webinar to be just a presentation of some technologies and be done with it, right? It's also a little more about, can we take it forward if your solution can be of help to someone else? And if you see this, there's somebody from Siddharth from Social Alpha. Hi. You could reach out to me on my mail ID that I'm mentioning here, and I could connect you to Mr. Buddhi to take this forward. All right. So this is the kind of an outreach and impact that we'd like to do through our presentations, through the webinar presentations, right? Mr. Ritesh, Mr. Pankaj, Devan, Buddhi ji, thank you. आप सभी आए, आपने अपना बात शेयर किया, टेक्नोलॉजी शेयर की, दूसरों को भी शायद मदद हो जाए. और Atif, would you like to talk about the vernaculars, please?
Yeah. So first of all, thank you everyone for your presentation. It was really nice knowing about the technologies and the startups that you're working on. So what we at IIM do with the Principal Scientific Advisors Office is that we host these webinars in vernacular language, so that you are able to reach out to a wider audience, so that your technology gets connected to many farmers and other industrial and other government agencies. So it's in vernacular languages, so it helps to reach